All right, let's talk about C++. For decades, it's been the go-to language when performance is everything. But let's be real, it's not always the easiest language to work with, right? It's incredibly powerful, but that power has always come with a steep learning curve and a ton of complexity. But what if that's finally starting to change?
You know, this isn't just some marketing slogan. This is the actual goal, the driving force behind where the language is headed. It's all about keeping that legendary bare metal performance while making the day-to-day experience of writing the code, well, a whole lot better.
And with C++23, that promise is really starting to become a reality. This is not just a handful of new features. We're talking about a major evolution that tackles some of the oldest, most frustrating parts of working with C++. So let's kick things off with a change to the core language that is, frankly, a huge deal. It's a feature that goes right after a massive source of repetitive boilerplate code.
Oh man, if you've been writing C++ for any length of time, you know this pain. You've got one simple member function, but you need 4 different versions just to handle all the cases. Const, non-const, R-value, L-value, it's just a ton of copy and paste. And this slide just says it all. Look at the left. That's the old way, 4 nearly identical lines of code. Now look at the right. In C++23, all of that just collapses into one single beautiful function template. 4 lines become 1.
So how does this magic work? It's a feature called deducing this. The big idea is that instead of having this invisible, implicit this pointer, you can now make it an explicit first parameter to your function. And when you do that, the compiler can automatically figure out everything about it. Whether it's const, whether it's a temporary, you name it. And just like that, the need for all those manual overloads just vanishes.
Now here's where it gets really cool. This simple feature has a huge ripple effect on more advanced patterns. Take the curiously recurring template pattern, CRTP. It's this super powerful technique for high-performance polymorphism, but honestly, it's always been kind of ugly to write. With deducing this, all the messy parts just disappear. It cleans up the code so much that it almost doesn't even feel like CRTP anymore. So C++23 is cleaning up our syntax, which is amazing, but it doesn't stop there. It's also completely overhauling the physical structure of our projects. You know, for the longest time, the biggest drag on C++ development hasn't been runtime speed, it's been compile times.
And the culprit has always been #include. Every time you include a header, the preprocessor literally copies and pastes its entire contents into your file, and the compiler has to parse it all over again, for every single file. It's a recipe for slow builds. Modules completely flip that script. You compile the standard library once into a binary format, and from then on, you just import it.
And the result? Well, it's a massive speedup. We're not talking a few percent here and there. For many big projects, we're looking at builds that are literally an order of magnitude faster. Swapping out pages of includes for a single, clean, import steed is an absolute game changer for productivity.
And it's not just about speed. Modules also solve the age-old problem of macro pollution, where a macro from one header accidentally breaks code in a totally unrelated file. It gives you a much cleaner boundary between what's public and what's private. And they've even thought about the transition. Import stand.compat is there to help you bring in older C-style functions without a fuss.
Okay, so we've improved the language and the build system. Next up, C++23 brings a huge upgrade to the standard library itself, with a real focus on making our day-to-day coding safer, cleaner, and honestly, just a lot more pleasant.
Think about error handling. For years, it's felt like a compromise. You could use exceptions, which are safe because you can't ignore them, but they can have a performance cost. Or you could use error codes, which are super fast, but it's dangerously easy for someone to just forget to check them, leading to all sorts of nasty bugs down the line.
C++23 gives us the best of both worlds with STD expected. As you can see here, it has the zero overhead performance of an arrow code combined with the safety of an exception. Why? Because the compiler forces you to check whether it contains a value or an error. You literally can't ignore it.
And what's really brilliant is how it transforms your code. It enables this pattern called railway-oriented programming. Imagine your code is a train running on a track. As long as every function succeeds, you stay on the happy path track. But the instant one of them returns an error, the train switches over to the error track. It lets you chain operations together beautifully, keeping your success logic clean and separate from your error handling. No more nested if statements everywhere.
All right, next up is a feature that pretty much everyone has been asking for. For like 30 years, C++io has been a choice between the clunky, slow IOStream and the fast but notoriously unsafe printf. Well, not anymore. C++23 gives us stdprint. And it's fast. I mean, really fast. Benchmarks are showing it's often 5 to 10 times faster than using IOStream. But even more important than the speed is that it's completely type-safe. If you try to print an integer using a strings format specifier, your code simply won't compile. That whole category of runtime bugs, just gone.
And for anyone doing graphics, scientific computing, or AI, there's standard MDSpan. Simply put, it's a standard zero-overhead way to handle multidimensional data like an image or a matrix. No more writing y times width plus x and hoping you got the math right. It's just a lightweight view on top of memory you already own, and its flexible layout support means you can write an algorithm once and have it run efficiently on a CPU or even a GPU.
Okay, all of these new features sound incredible. But the big question is, how do you start using them in a massive, existing code base without just stopping everything for a year to rewrite it? The answer is, you don't. You do it strategically in phases.
You start with the easy stuff, the quick wins. Phase 1. For any new logging, just use std.print. Look for simple loops that can be replaced with new ranges algorithms. These are often easy drop-in changes. Then, in Phase 2, you get a bit more architectural. Any new function that can fail should use std.expected. Finally, in Phase 3, you tackle the big stuff, like converting small, self-contained libraries over to use modules. It's a journey, not a light switch.
And the best part is, the tools are ready for you right now. The latest compilers from GCC, Clang, and Microsoft all have solid C++23 support. Critically, modern versions of CMake can now handle modules properly. When you pair these with modern tools like static analyzers and sanitizers, you have a really robust ecosystem to help you make this transition safely.
So here's the bottom line. C++23 isn't just another version number with a few extra bells and whistles. It represents a real shift in the philosophy of the language, making it safer, more expressive, and more productive, all by default. It's a true evolution. So the real question isn't about the language anymore. It's about your code. Is it ready?